this is a long one. We're almost done. Okay, so now let's talk about graphing rational functions. So there are 4 important pieces that you need to look for when you're graphing rational functions. We're going to talk about the first 3, and then we'll address the 4th. So the first 3 things that you can look at for a rational function is we can find the roots or solutions or x-intercepts. Those are, remember, all the same thing. They're all the point where my graph crosses the x-axis. Vertical asymptotes. Quick review of asymptotes. If you're not sure what they are, go Google them. But quick review, an asymptote is an invisible line that a graph gets closer to but does not ever cross. Okay, vertical asymptotes, they can never cross them. So they get closer and closer, but they do not touch. And then a removable discontinuity is probably something new, and that is where we get a hole in the graph. And I'm going to show you what that looks like and how we find those. Okay, so going back up to roots or solutions, when we find a root or solution, what we want to do is take the numerator, the factors of the numerator. Okay, so these come from the factors of the numerator equals to 0. Okay, so I'm going to take the factors of the numerator. So 2x would equal 0, x minus 3 would equal 0, and 3x plus 1 would equal 0. Okay, and then solving those, I know that then my roots or solutions, I would have x equals, from this one, I would have x equals 0, right, divide by 2, positive 3, and negative 1/3, coming from each of these pieces. Those are my roots. Okay, so that means that on my graph, I would have x equals 0, I would have 1, 2, 3, and I would have at negative 1/3. Vertical asymptotes come from the roots of the denominator. So I want to say x minus 3 equals 0 and x plus 4 equals 0. So I have horizontal asymptotes at positive 3 and negative 4. What that looks like on my graph is at positive 3, I would do a 1, 2, 3, an invisible line. So we make an invisible line using a dashed line because obviously we can't draw something invisible. So we're going to draw that one. And then x plus 4 would be a negative 4. So it's going to be somewhere over here. Okay. Now, you might have noticed this and thought, wait a second. Look what happened. I had a root solution x-intercept at 3, but I also have a vertical asymptote at 3. Okay? And we just talked about asymptotes and how the graph can never cross those or touch those. So when that happens, when I have something that's repeating itself on the top and the bottom, like this x minus 3 and x minus 3, it is no longer a root, and it cannot be a vertical asymptote either. Something weird is happening there, and that is a removable discontinuity. So a removable discontinuity happens when I have a factor on the top that is the same as a factor on the bottom. That value cannot possibly be a point on the graph and an asymptote. Those contradict each other. So instead, our graph is going to kind of freak out, and we're going to have a hole there. Okay. So if, for example, there are a lot of different graphs that could have these qualities, but if, for example, my graph, it crossed here, like this. Okay. So if I had a graph that looked like this, for example, okay, what we would do with the hole is we would find where, so we know that our removable discontinuity is at x equals 3. So,